Okay, hi, this is Jadi and I'm back. I was playing another CTF today and thought it's nice to share because the challenge was very cool. We started this very late, nobody played from my team, but I just opened it and tried to solve one of them and it's finishing and solved this almost perfect. You can see it has 66 solved, so it's not difficult, but it's very fun. I really enjoyed. You can see in my feedback, I say very, very cool and fun. Thanks, guys. Because when you start playing the CTF games, after some time, they become repetitive and you will think same patterns, so new things are fun. It has a file, you can download this. This is the OMH challenge. And it has a bounties. I'm not sure why my team didn't play this one seriously, because they have a 1,500 for the first team, for the second team, for the third team. If we could do with all of our forces, I believe we would be one of the first 10 teams and we may get a prize. Anyway, I downloaded this. So to check that, I will go to to my temp directory. We'll create a directory, whatever, cp, from downloads 6e. No. E6. No. So we have to check what was the file, 6e. So here I will say from the downloads 6e, download it here, copy it here. tar_xf will open the file. So CD almost perfect for players. We have two files here. As always, I will run the Tmax to make working easier. Less output. This is the output of the cryptographic thing they did. Not much data, but you can see it's in the form of the normal text. But if you check the words, they are not normal words. But the whole thing looks like an easy cryptographic pattern. I will go with almost perfect. We'll open it here. I have done this once for sure. You saw that I have already resolved it, but just want to show you how the whole procedure goes. So they have one function, which is their main function. It's here. It generates a key. Key equals join random choice from the strings for anything in length of the key length. It is set here 14. So this will create a random ASCII lowercase only letters. And it will create a key. Then we'll show the key. Then it will read the data from the data.txt. We'll read it. We'll decode it, okay, and we'll split based on the characters. We forgot to reread the question. If you never encrypt data longer than the key, then it's just like one-time path and cannot be decrypted. If your key is longer than your data, it's a very good key because it's not reusing parts of itself. This is a general rule in cryptography. But it says, okay, if this is it, so it's great, let's do this. See what it does. It reads the data, splits the word based on the space. So if I come here and we'll go with less with output. So it separates every word based on the space, then opens the output file. This is the file we are looking at. Write into it, encrypt data. Let me come here. Encrypt data with this key and the normal encode, which is a Python thing. So the main part is happening here. It reads. Before that, it checks if every single instance of this is correct. This is what all does. So it says in character set C. In character set says return if length of this equals 0. Set C, let me show you what it does. This is not just for solving it, this is for learning. I will go to my IPython. So what it does, it reads data with this command, right? So if I repeat this, but instead of output data text, I will go with output text. So if I check the data now, this is all the words separated in the list, right? Then it goes with encrypt data and the key. And we have a key with a length of 14. It's only lowercase letters. So what does encrypt data do? It says ensure perfect secrecy with data. This is the function, ensure perfect secrecy. This checks if length of C, that character, is smaller than the key length. So we'll check if every single word in data is, the length is smaller than 14. If it's not, it will say I cannot work on this. It will give us assert. This is just a check. So practically we don't need this. I can just forget about this function to make the program much easier, because it just checks if any word in my data is longer than 14 characters or is longer than the key length. It will give an error and will stop working. So this is the first part. Then it goes, creates a shifts list for every character in the key. Let me do this so I'm not, this is the data, right? And we have a key which is like this, A, B, C, D, E, F, G, up to 14, whatever. Okay? We can even repeat this command and get a key. It checks the difference between the first character and the A. Here it is 0. So the shift first will be 0. Then B with the A, so it would be 1. It's looking how many characters I should shift each key. So if this is my key and I want to encrypt AB or I don't know, CD, what I will do is, okay, A, the difference with the A was 0, so it will give me back C, the same thing here. B with the A was 1 character, so we'll add 1 character to this, A, B, C, D, E. So this will be my encrypted text. This is a normal shift encryption with the key. Okay, so this is the whole logic. This is what will happen here. And this is the whole thing this system does. It reads whatever is there, looks how many characters I'm further than A in my key, and will add them to this input and will write it to the output. This is the whole thing which is happening. But here we have an encrypt data versus encrypt. We are calling encrypt data. What encrypt data does, it returns. It puts space between each character and will encrypt the word by word. This is where the programmer done its main mistake. If I come out and I will show the output, what it does, it creates a key with the length of 14. Then it will encrypt the first character with this key. Then the second word, with this key. Then the third word with this key. So we have a key in which we have encrypted all of our words one by one. First this word with that key, then this word with that key, then this word with that key, then this word with that key, and it assumes that always whatever you are encrypted is shorter than your key, so this is secure. But it's not, because you should not repeat your key. This is the worst case scenario. So let's see how we can crack it. We have found out that there is a key. It is every single word is encrypted using that key, and also we know that this key is repeated. So let's type our encrypted word. This is it. Sorry, I selected this encrypted word and it's a shift encryption. So I can say online shift decrypt. There are different sites. There is one famous site with the .fr, this one. It can help you in many places, but there is one much cooler, this crypty.com. This is much easier. Normally it goes to the Caesar cipher. Caesar is just, for example, adding 7 letters to I, which makes it the P. Then 7 to this. This is not what we are going to do. We have a key. So I think this is ours. Yes. This Vigenere Cipher or whatever it is. And we want to decode. This is our main text. This is our output. And this is our key. We have to start finding a key. In the beginning, it is very difficult, but as much as more letters you find, everything becomes easier. So we have PM here. We have to have something here. If it was AA, our output would be PM because the difference between A and A is 0, so this wasn't changed. If this was B, I would have O here because LMNOP, so going 1 backwards. Remember, when encrypting, we are going forward. When decrypting, we are going to backward. So what it should be? Here, you need a cryptographer's eye. 2 letters in the beginning. It's going to say some text. And it has 2 letters here. What is it? It. Most probably, this should be it. It's very easy to guess, but we can guess. It can be as or whatever. Or if someplace we have only 1 letter. For example, H. This should be A, most probably, because it should be I or A if we have only 1 letter word. So I will assume that this is A. And you remember, each letter was each word was separately being encrypted with a key. So my key should create A from H. I can try and see what will happen, but I can also create a very, very small IPython line here. I can say I want a CHR. What will happen if I check what number is associated with A minus ord of A plus ord of A. This will give me the A, right? Because A minus A plus A is A. Now I can say I want to convert, what was it? H to A. So check H minus A. I will find the difference. Now I have the difference. I will add the A to see what will happen there. This is H. So if my first letter of the key is H, this will become A. So the first letter should be H. This can be if and not it. If it's it, HH will make it a if. Let's go with this one and see what will happen. If. Okay. Now this word. I'm just deleting this, so the same key will apply to this. If ONA, we know these two are correct, we need another one here. What is it? This is 1. So I have to convert H to E, because this is my input, this is my decoded text. First 2 keys are HH, and this should become 1. This is just a guess, because ONA is not a word, 1 is a word. So I want to convert H to the E. Let's go for that one. If I want to convert H to the E, this should be D. So the first letter should be D. If 1, nice. What is this word? If 1 uses, this should be S. If 1 uses, I'm just creating the words. See what's the difference between the normal one? Normally, this Vigenere, if I pronounce it correctly, although I'm not pronouncing anything correctly, if we want to decrypt this, now PM, okay, space is not being decrypted. So PM is decrypted with HH, which become if. Then this one. But here we have a different methodology which just encrypts and decrypts words by word. So practically now I am only decrypting VUH. VUH will become 1. Now I'm decrypting BZH. BZH, which HHD will become UZN. Because my key is only 3 characters, BH will give me U, ZH will give me S, HD will give me E, then this key repeats. So now again B is used on H. But I know that my key length should be 14. So I need another character here which makes this correct. This should be uses. So H should become S. Let's see what was it? U should become S. I want to create a S. I have the U, so I need a C. Now what I have here? H will become A, this is good. Key, see? That, because I have the 4 letters, so every 4-letter word. If one uses key, that is. Now I have a letter word which is larger than 4 characters. Truly. So I need to convert D to Y. What I need on my key to do this? I want to convert D to Y. Capital L. What it should not be capital. This is a problem. Maybe Y to D. Maybe we. No. I can just try. Because this circulates and I have to find a reminder and everything, but I don't want to spend time on that one, but I can try. See, if I put A here, this will become D. A, B, this is going backwards. This one is going backwards. So, E, F, so this should be F. This will become truly. Let's go for the next word. Randoy, this should be random. So, P should become M. Let's try. P should become M. D. See, we are just finding key 1 letter at a time. And the key is used on each of these. So this will be is, at, least, as, long. I'm reading here. I'm just deleting the other ones because I need larger words to find the next letters on my key. Encrypted, because it cannot be encryption. So L, S should become T. S should become T, S cannot should become T. So I will try same as I did. Okay, now we have encrypted message. I'm looking for the next long word so I can find the Vigenere. This is good. Theoretically, maybe, let's see. Theoretically. So J should, no, sorry. First, theoretically, B should become A. B should become A. E, and L should become T, L, L should become L, L should become L, and C should become L. Okay, and at the end, J should become Y. J should become Y. So R still not working. So A, B, C, D, E, F, G, H, I, J, K, L. Okay, theoretically unbreakable. Let's see what's the length of the key we found. Len of this 13. We still need one letter. What is this? We have to look for the larger words. Cryptographic strength. What is this? I can come here. I had the data, right? No, I closed that. Let's see if I have it. Okay, I read the data. For I in data, print if len of data equals 14, print data. We didn't have any. Really? What is this? Polyalphabetic. So M should become C. This is our last letter. Why didn't this work? But anyway. C should become, T should become C. So this is the R. No. M should become C. So M should become C. The K will be here, the last letter. So now we have our key. We can change this program here. Because when you have this kind of cipher, encryption and decryption are kind of the same. Here you add the shift character, it's enough to decrease it. And also here, you read the key, you don't need to read the key. This is the key. Print the key, data, read the data from the output. Read, split based on this, do not need to assert. You don't need to check any of these. So here I'm reading the data, I'm sending it to the same thing, but instead of adding the shift characters, I'm decreasing the shifted characters and writing the output. So let's run it and see what will happen. I will have Python almost perfect. Now I should have cat output. If one uses a key that is truly random, it is based on encrypted message, read everything, the weakness, flag is flat curly braces this. So now we have the flag. I believe this was a very cool and interesting. So I will replace the curly braces with the curly braces. And this is our flag. Not so perfect, polyalphabetic shenanigans. I believe this was very cool. I really enjoyed it because it was fun. It was different that we are always used to solve. So I enjoyed it. And here you can go and submit the flag. Then it tells you to rate it. Hope you enjoyed this. I will be glad if you follow. I will make parts of this on a fast forward because you didn't need to wait for all the time for me to checking things. Have fun. This was Jati.